Okay, so I want to look at chapter 9, number 22, which looks complicated, but it's actually pretty simple. So the intro paragraph here is describing stuff that we did back in chapter 3, which says if you invest $1,000 on this date right there, and it pays 6% interest every year, then 20 years later, you could figure out the value of it by just taking 1,000 and multiplying it by 1.06 to the 20th. So this was the interest idea that we learned way last semester. So, but that's not usually how most investments account work. You don't just put in $1,000 and then wait a 20 year and wait 20 years. You usually put in $1,000, and then maybe a year later you put in another $1,000, and then a year later you put in another thousand. And so, if the account interest is always 6% a year, then your total is not going to be the same as just this because you've kept adding to the account. So instead, after 20 years, it would be worth this if you put in $1,000 every year. And the way to interpret that is, well, let's look at this. In 2012, you put in $1,000. So let me write it this way. $1,000 in 2012 is worth 1,000 times 1.06 to the 20th in 2032 because it's 20 years later, right? And then in 2013, you invest $1,000 in the same account. So you add this to it, right? But that's worth 1,000 times 1.06. Now this was invested for one less year, so it only has 19 years to get interest on it. So that's going to be in 2032. And the $1,000 that you invest in 2014 will be worth 1,000 times 1.06, and now it has 18 years to gain interest. And so you can keep this going all the way down to the $1,000 that you invest in, let's say, 2031 first. And so that one only gets 1 year to accumulate interest. So it's to the first in 2032. And whoops, that's 1,000. And then in 2032, that's the final year, you add in $1,000, but it has no years of interest to accumulate. So it's really 1,000 by itself, or you could think of it as 1,000 times 1.06 to the 0, which is really the same thing anyway. So then you can say, okay, if I invest $1,000 every year for 20 years at 6% interest, then the total value will be the sum of all of these. And that's what we have right here. Here's one of them. Here's another one. I left out the squared, but here's the 19th and here's the 20th one. So these are really each of the year's investments at the time July 1st, 2032. Okay. So in part B, it says, let's try and figure out a way to add them all up. And adding them all up, there are 21 terms. You could type in all 21 of these on your calculator and keep pushing plus. But there's a shortcut for it. And if you look at this sequence up here, or this series up here, it's geometric, right? The first term is 1,000 times 1.06 to the 0, which is still 1,000. The second term is the first term times some constant. The third term is going to be that one times another 1.06, right? The nth term is going to be 1,000 times 1.06 to the n minus 1. So what we can't do, and it even gives us this shortcut here. I'm going to call the entire thing v and just rewrite the original line. 1.0, actually, I'll just write it as 1,000 plus 1,000 times 1.06 times to the first plus 1,000 times 1.06 squared plus dot 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 plus 1,000 times 1.06 to the 19th plus 1,000 times 1.06 to the 20th. And then the trick says multiply both sides of that equation by 1.06. So here we go, 1.06v. Well, that's going to take this 1,000 and turn it into 1,000 times 1.06. So I'm going to write that one here. And then it's going to take this term and multiply that by another 1.06. So you end up getting 1,000 times 1.06 squared. And if you keep going with this pattern, when you get to the 18th term that's right here, it's going to be 1,000 times 1.06 to the 19th, because we multiplied it by another 1.06. And then the 19th one is going to turn into 1,000 times 1.06 to the 20th. And then we've got one extra term here. The 20th term is going to turn into 1,000 times 1.06 to the 21. Let me shrink this down just a little. Okay, so now we've got this. We've got two sets of equations here. And the convenient thing, now there's one more trick. It says subtract the original equation from the resulting one. So if I subtract this entire thing, I've got v minus 1.06v, and then I've got 1,000 minus 0, which is 1,000, and then this one minus this one, which cancels. These cancel. All the middle terms will cancel. These cancel, and I'm left with 0 minus this. So it becomes negative 1,000 times 1.06 to the 21st. And now if I factor out the v, and I'll just factor out the 1,000 here too. And then I can divide by the 1 minus 1.06. And you might recognize this as the shortcut formula for geometric series sums. It's that the sum equals the initial value 1 minus the rate to the n, where there are n terms, all over 1 minus r. So that's kind of that form where that comes from. And if you actually plug that all into your calculator, do I have that here? Yeah, you get about $39,992.73. Okay, so that's part B. Part C is asking basically the same question, but now it's asking what happens when it's in general form. So that's this. That's the series right there. So if I write this out, sum equals a plus ar plus ar squared plus dot 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 plus ar to the n minus 1. Well, the trick that we just used was I multiplied everything by that, which was the rate, the common ratio that I was using. Well, that's r in this case. So if I do rs, multiply every term up here by r, and it turns into just an additional power of r. So instead of a, it becomes ar. Instead of ar, I get ar squared when I multiply by r. And then it keeps going. I've got an ar n minus 2 right here that I haven't written out, but that turns into this. And then I get an ar to the n, because that's what this one turns into. So if I subtract, I get s minus rs equals a minus 0. These guys all cancel. And then I've got minus ar to the n, because remember, it's 0 minus this one. And if I factor out the s, and factor out the a, and then divide, that's what I get. Now here it just says a, not a1, but if you notice in this, the first term is a. So it's really the same thing as this equation that we just wrote up here. Okay, hope that helped.